Okay, welcome to method 3 for finding the equation of an exponential function. I have already made videos about method 1 and method 2, and you're definitely welcome to watch them. My students should really watch all 3 videos and practice all 3 techniques. The techniques are not very different. They're necessary because which technique you use to find the equation of the exponential will depend on which values you have in your table of values to work with. So method 3 involves not having the y-intercept, not having the point where x is equal to 0, not even having the point where x is equal to 1, and in fact having points where the x values are not very close together. So a table like this where instead of having 3, 4, 5, 6, which is a method 2 style, we're jumping 3, 6, 9, 12. So the x values are noticeably distanced from each other. But of course we can still do this. So I'm going to show that method now. The first thing, of course, is to do the tests to see if this really is an exponential function. My lesson about how to do the test for linear and quadratic is a separate video, which will also include the test for exponential. But here, all I'm doing is the last test for exponential, which is the constant ratio test or the constant quotient test, which is set up right here. This is where you take the second y value and divide it by the first, you take the third and divide it by the second, etc., and see if you keep on getting the same answer. Where is my calculator? With these decimals, it will help to have the calculator. So I have set that up. Second y is 5.315. I'm dividing it by the first y, which is 3.993. I will do that now. 5.315 divided by 3.993 equals 1.331. So it is rounding to 1.3. Second division, 7.074 divided by 5.315. 1.33, etc. It's also rounding to 1.3. And then the third one, 9.415 divided by 7.074 equals 1.333. Okay, so it is rounding. I could write 1.33 because all 3 of them actually rounded to 1.33, but it doesn't matter. They're rounding to the same. The answers I get to my divisions are the same, or they're extremely close. And when that happens, it means that this test has proven that this is an exponential. We'll find the equation for it soon, but I'm going to do this one as well. So I've done the exact same thing. I am dividing the second y coordinate by the first y coordinate, etc. So let's get busy and do it. 4.48 divided by 2.59 equals 1.7297, so I'm going to say that rounds to 1.7. 7.74 divided by 4.48 equals 1.72, also rounds to 1.7. And finally 13.37 divided by 7.74 equals 1.727. It's also rounding to 1.7. So the constant quotient test, constant ratio test is telling me that this is an exponential function. Both of these are exponential functions. Let's get busy and find the equations using method 3. So method 3 is very similar to method 2. We start by writing the form of the equation, which is y equals a times b to the x. Then we fill in that form twice with 2 of the points from our table, but we put a point that's lower down in the table has a greater x value on top, because we're going to divide the equations once we have filled them in. So I'll use these first 2 points. When I plug them in, I have 6 equals a, sorry, not 6, slow down, Doug, 4.48. I'm going to move the whole thing over this way a little bit so we can see it. 4.48 equals a times b to the 6. And then we are dividing that by a second equation, which is going to be 2.59 equals a times b cubed. Messy. Cubed. There. When I divide, this looks the same as method 2, because it is the same as method 2. There's just one slight difference that we haven't really gotten to yet. The a divided by a cancels, which cancels the a's out, and we wanted that because it helps us to isolate the b. 4.48 divided by 2.59, we already know it's going to give us 1.7. I can be a little bit more fussy. 4.48 divided by 2.59. If I decide not to round so high, 1.7297. I'll call it 1.73. And then b to the 6 divided by b cubed. We actually have to use our understanding of the laws of exponents a little more when we're doing this method, because the x values are not as close together this time. B to the 6 divided by b to the 3 is equal to b to the 6 minus 3, which is equal to b cubed. And then, to simplify this, not so obvious when you have a decimal here, you have to be able to use the keys in your calculator. So the y to the x key in this calculator, if I do the second function, the shift, is the x root of y. That's what I need. So I am plugging in the 1.73 and the 3 with that key. You have to know how to use that key in order to figure out what b is equal to. So I'm going to do that now. Forgot to turn the calculator on. That's always going to happen when you're videotaping, isn't it? Second, y to the x. Okay, so I want a cube root, so I'm plugging in a 3 with this calculator. Different calculators can work a little differently. Plugging in a 3, then I'm hitting the second function, y to the x, which gives me the x root of y. And then I'm plugging in 1.73 and hitting equals. And I get a value that rounds to 1.2. It's 1.2004, etc. So it means that b is equal to 1.2 if I round it. Therefore, I can fill that in with my form. Y is equal to a times 1.2 to the x. And now the step to find the a is the same as it was for method 2. This is slightly different because of how you're using the keys in the calculator, but this second step is the same. So I'm plugging in any of the points that I want to. I'll choose this one on the bottom because I'm a show-off. So I'm going to make y equal to 13.37 equals a times 1.2 to the 12. Oops, do my parenthesis properly. Now I'm simplifying. I need to do 1.2 to the 12. I'm kind of asking for it here. Let's see if it goes into scientific notation, which I don't really want to do. 1.2 to the power of 12 equals, no, 8.916, etc. So I'll call that 8.92. And I have 13.37 is equal to 8.92a. Now I just have to divide both sides by 8.92. I'm making sure this still fits on my video screen. 8.92. 8, you can tell I'm right-handed by how messy my handwriting is right now. 8.92. Cancel, cancel. Will this fit if I write it? Yes. A is equal to 13.37. 13.37 divided by 8.92 equals 1.4988. I'm going to round that to 1.5. More chalk, please. Okay, now I can write my equation. So the equation in this case is going to be y is equal to 1.5 times 1.2 to the x. And then, of course, if we're in a word problem situation, we would probably be needing to plug values into that equation in order to answer the final question. But this video is not about a word problem. This video is about how do you make sure that with the test that it is an exponential, and then find the equation of the exponential with this sort of simple two-step process, even if you have x values like 3, 6, 9, 12, whereas they're not doing you the favor of giving you 0, 1, 2, 3 or something that seems simpler. But even this method is simple once you know how to do it. Okay, let's find the equation for this one. It's the same method, y equals a times b to the x. I am plugging in, I could pick any 2 points, but I am plugging, I think this time I'm going to plug in the third point and the first, just because I feel like it. I want to make the extracting of the x root to be more challenging. Okay, so therefore, third point, 7.074 is my y, is equal to a times b to the 9. There. And I am dividing that by 3.993 equals a times b cubed. When I divide, the a's cancel. We knew that would happen. B to the 9 divided by b to the 3 is equal to b to the 6. And 7.074 divided by 3.993.993 equals 1.7716, etc. I'm just going to write 1.77. Now I have to find the sixth root of 1.77. That involves plugging in with this calculator 6 second y to the x key 1.77 equals. And I get 1.0998, so it's 1.1. It's rounding to 1.1. B is equal to 1.1. We write our form again. Y is equal to a times 1.1 to the x. And we plug in any point we want. I don't want to use one of the points I've already used. I'm going to use this point here. 5.315, so I replace y with 5.315 equals a times 1.1 to the 6. Simplifying 1.1 y to the x 6 equals. That's giving me 1.77. Sound familiar? It's giving me 1.771561. So I have 1.77a equals 5.315. I'll divide both sides by 1.77. Is this still fitting in the video? Yes, it is. 1.77. Cancel, cancel. A is equal to 5.315 divided by 1.77 equals 3.0028, so it's A is equal to 3. So therefore I have the equation y is equal to 3 times 1.1 to the x, and I can plug values into that equation if I need to in order to answer my final question. Let me see, I'm double checking that I didn't make a mistake. Wow, they're correct, because this is not difficult, but you have to practice it. Since there are three methods that are slightly different from each other, a student who only practices each method once is going to get them confused and then feel lost when they need it. If you do a few of these for each method, then you get to the point where you start saying, I don't want a table of values where x are equal to 0, 1, 2. That's too easy. I want something really, that I can sink my teeth into like this. Okay, we have covered, in this set of three videos, we have covered all three methods for finding the equation of the exponential function. If you haven't watched the other two videos yet, watch them. And also look for my video about doing the tests for linear, quadratic, and exponential, because that also helps you. Because in the course that I'm teaching, not every question is about exponential. Some of them are about quadratic, some of them are about linear. You have to be able to approach a table of values and figure out which one you have before you'll know what steps to follow. With that, thank you for being with me for this video. It was fun. Don't forget to take a baseball bat to that like button and promote my video to all of your friends and family and other people who don't really necessarily want to know what videos you're watching on your social media, so that I can become rich and famous. I'm looking forward to that. Thank you. Goodbye.